welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as always, and on the bench we have an MG30 CFX. Not an amp I'm familiar with, one of the new Marshall, newish Marshall amps. The problem with this amp is that it makes a horrible loud hum. So without messing about any further, let's turn it on and see if we can hear that said Orrible Okay, the amp is plugged in. Let's press the power button. Whoa! That's a horrible hum. Not at all gain dependent, no control affects it. Let's see if we've actually got a signal there. Let's see if the amp's actually working. No. Although interestingly these LEDs are on, which means some of the voltage is okay. Hang on. No, nothing there at all. Okay. Not sure what that is. I doubt this has an effects return on the back. No, nothing. Not sure what I'm going to find when I take this apart. It could be some brand new switch mode power supply, jobbie or something, I don't really know. But we will take the back off and then take the chassis out and have a look to see what we've got inside here. Okay, it was quite hard getting the chassis out, but I managed to do it. And as you can see, we are in a bit of trouble here. We've got circuit boards with surface mount chips on and that sort of thing. Nothing fixable here, so all we can hope for and check for is that maybe there's something wrong with this power supply here, and that's why we're getting that horrible hum. This will be the power amp here, just a couple of power transistors on a heatsink, nothing fancy. Can't see anything obviously wrong. So we can check these diodes. That board's not too hard to take out, so maybe we can also check these smoothing caps here and see if we've got any decent voltages around the place. Not holding out a lot of hope for this one, I'm afraid. Slightly above my pay grade with all this. That's a crystal, so some sort of a microprocessor or some sort of digital signal processing on this board. I don't think this board's probably faulty, but anyway, we'll have a little play around, see if we get lucky. Okay, so we'll turn it on and we get horrible hum, and I've unplugged this connector here from this signal processing board here, and that tells me that the problem is in this power amp section here. This whole front board here you can't see, it's got a printed circuit board behind it with loads of surface mount gear on it, but that board connects into here via this ribbon cable, and then from here to the main amplifier via this. So we've eliminated all problems with the whole preamp section and the signal processing board. It's something to do with this board here. So I think the next thing to do is maybe take this board out and just have a little look, see if we can see anything. Okay, I've got the board out and I've done quite a few checks on it. I've checked the diodes, they're okay, these capacitors are okay, this capacitor's okay. Then I noticed that actually the way they do this, I thought actually it was a couple of power transistors, one here and one on the other thing, but actually what they're doing is they've got an audio IC, where are we, there, and that's a TDA 2050, which is some sort of audio power IC, might be 50 watts, and I suspect that that has gone down. I've measured plus and minus rail voltage, that's all steady, and the only thing that can be down is that IC. So it's a question of do I have one in stock that I can change that with. Well, amazingly, in my goodie box I do actually have a couple of TDA 2050s along with some other ones. So I think we'll take a view on this and bung this IC in and see if that cures it. If not, we'll have to call it a day on this one. So let's push ahead with that. Right, the first thing we'll do is remove the screw holding this down onto the heatsink. Then I'm going to attempt to remove this with a some solder wick and hope that does the trick. Sometimes it works well, sometimes we struggle a bit. Let's have a go, see how lucky we get. Seems to be working fairly well. Right, bit of luck that might come out of there. Let's see how we get on. Stuck down to the heatsink, of course, with heatsink compound. That blade won't go in there. Let's try something else. There we go. That's taken it off the heatsink. And then with a bit of luck, there we go. So let's put that to one side. Now I need to go and find some heatsink compound. You don't need much, just a little smear like that on the heatsink. And then we pop that in. Not quite so easy since we have to get down through the veins of this heatsink here. Quite tricky that actually. Let's try with a pair of pliers. Okay, I'm just going to check the lead spacing on this one compared to the original. Yeah, it's not so different actually. Okay, well, this is the moment where you accidentally put the original back in. Maybe space those out a little bit more. Let's have another go. It's quite awkward this because of this heat sink here in the way. There we go, that's got it in. Fantastic. Now we put the screw in first, don't solder it and then try to screw it in. Always put the screw in, then do the soldering. Like so. Good. Now we can solder it. See, it doesn't take too long to change that chip, and they're only sort of £4 each or £5, so it's definitely worth doing it. I would put a 75% chance of it being this chip that's faulty. I don't know what that other power transistor is on the other side of the heatsink there. I did check it and it wasn't short circuit or anything. There we go. A little bit of cleaner. By the way, I don't know if you've noticed, but this board has all sorts of surface mount chip resistors and diodes all on the back there, so it's not a fixable board in that sense, at least not by me. I don't do surface mount stuff, it's just a little bit too fine. I don't have the tools and things, and you know, look at my hand. I mean, I just can't do any surface mount work with that. It's hopeless. I don't know why. Right, we can test that, and we'll soon know whether it's working or not. So let's get that set up for a test. Okay, moment of truth. You're seeing it as I'm seeing it. I haven't turned it on yet. Plugged in. Here we go. 3, 2, 1. Ooh. Ooh. I'm liking the sound of that. Plug a guitar in and see. Sounding promising, this. Oh yeah. That's a fix, people. Nice. So that was the fault. This little TDA50 IC. They do go faulty for reasons unknown, so that's great. That's a good little fix, that. Otherwise this would be landfill, you see, because this is a modern amplifier, surface mount chips all over the place, not really fixable, and this is modern construction for you. When it goes wrong, it ends up in a skip, which is really quite shocking. There you go. It's all about production costs and keeping the price down for the consumer as far as possible. Right, well, we'll get this one back together and consider that to be a wrap. Okay, so there you go, an MG30 CFX, one of these very modern amplifiers with a little integrated circuit to do the power, tons of surface mount chips, lots of digital signal processing to give you all the chorus and flange and all that sort of stuff. Built to a budget, quite cheap to buy and impossible to fix unless it's a fairly obvious fault on the power supply board or on the power board. So we were, well, I was going to say lucky, but it couldn't really have been much else other than that chip once we'd established that all the smoothing caps and all that were okay and that the rails were okay. So they're always a good go-to, those little TDA chips, and I've got a good old stock of them and I've changed a fair few. So there we go. I hope you enjoyed that one. Another amp saved from landfill, which is my mission in life. And I'll catch you on the next video. Thanks as always for watching.